So this lecture is on converting infix notation to postfix. That means Polish to reverse Polish notation before we can do any evaluation. So I'm going to do two examples. This first one says a plus b times c minus open parentheses. So now the order of operations, you know that exponentiation comes first, then you have division, you have multiplication, division, modulars, and then you have plus and minus. So this is the order. So exponentiation has the highest part. Now let's see that. This is an operand, so let's append it to my postfix expression. That's an operator, which is a plus. The stack is empty, so I'm going to push this stack now has a plus. That's an operand, b. I'm going to attach it to my postfix or reverse Polish notation. Now here's an operator. That's a plus multiplication. Now that's a is it greater than or equal to what's at the top of the stack, which is a plus? Yes, it is greater than. So since that's the case, I'm going to push it onto the stack. So now my stack has multiplication and addition at the bottom. Now this is an operand, c. I'm going to write it out. Now I see an operator. That's a divide. Is the divide greater than or equal to the multiply? Yes, it is equal to. Since that's the case, I'm going to pop the multiplication. I'm going to put it right there. So the stack now is, so I pop the multiplication. After I pop the multiplication, this is what I have. So I'm going to continue. Is the divide greater than equal to the addition? Yes, it is. So I'm going to push the divide into the stack. Open parentheses. Whenever I see an open, just push it into the stack. Now e, add it to the postfix expression. Now there is a minus. Well, the minus, the top of the stack is an open, so there's nothing there. Just push. So now this is what I have. Then you have f. Write it out. Okay. Then you see a closure. Try to pop everything from the stack, including the first opening. So I'm going to pop the minus. Okay. I'm going to pop the matching closing parentheses. Since I'm done, I'm going to pop the rest of this stack element. So then your stack becomes empty, and that's how it checks for valid expression. So this is now my postfix expression. So from infix here to postfix. Okay? So I'm going to go do the second example. Second example says, okay, postfix expression. 6, which is an operand, write it out. Multiplication, go into the stack is empty, push the multiplication there. 4, right, attach it to the postfix. Remember, this is my postfix. There is a plus. Well, check this. Is the plus greater than equal to that? So it's not. Since it's not, I'm going to pop the multiplication, okay? Now the stack is actually empty. So now I'm going to push the plus in there. There is a 2, write it out. Then there is exponentiation. Is exponentiation greater than equal to the plus? Yes, push it in. Now there is a 5, write it out. Okay. Now there is a minus. Well, there is a minus subtraction. Check out the subtraction. Is the subtraction greater than or equal to that? It's not. So let's take the exponentiation out. That's exponentiation. Take it out. So once I take it out, there's a plus there. Now check if the minus is greater than or equal to the plus. It is. Take the plus out. You are done. So there's nothing in the stack. Push the minus in there. Minus is in the stack now. Now there's a 3. Write out 3. Okay, I'm done. I am done, so I need to empty the stack. So I take everything out. So this is now my postfix expression. 6, 4 multiply 2, and there's a 5 here. There's a 5 exponentiation plus 3 and minus. How do you evaluate? So I have this expression. This is my postfix expression. I want to evaluate. For me to evaluate, I have to use a stack. So this stack may go on. The issue with the stack is that when I see an operand, like 6, I'm going to push into the stack. Another operand, I'm going to push into the stack. See? Nothing about that. Now I run into an operator. Whenever I run into an operator, I have to pop the stack once. I have to pop the stack twice. So 6 times 4, so I pop the 4, I pop the 6. Then I apply the operator. 6 times 4, that's 24. I'm going to push 24 into the stack. See that? There is a 2, push into the stack. There is a 5, push into the stacks. See, that's a 5, push into the stack. So whenever you see an operand, you don't have to worry about, just push into the stack. Now there is an operator. There's an operator. Pop the stack once, pop the stack twice, apply the operator. So 2 times 5, 2 to the 5th. It's 2. So 2 to the 5th is 2 times 2 times 2 times 2 times 2. So this is 4, 8, 16, 32. So I'm going to push 32 back into the stack. 2 to the 5th is 32. I'm going to push 32 back. Now there is a plus. Well, since there is a plus, I have to pop the 32 and the 24, and I'm going to apply the operator. So I pop the 32, I pop the 24. When I apply this, so that gives me 56. So I push 56 into the stack, okay? So that's when I saw the plus. Now there is an operand, push. There is an operator. So pop the stack once, pop the stack twice, apply the operator. See, pop the stack once, pop the stack twice, and apply the operator, and then push 53 into the stack. And this is my final result. So my final result is 53. Now here's the deal. The stack pointer has to be at 0 for the last element to be there. Otherwise, this is how the computer checks, or the process checks for invalid expressions, syntax error, in case I left out an operator or something. So now, 6 times 4 plus 2 to the 5th power minus 3, the result is 53. And this is how we convert from Polish notation, reverse Polish notation, and then we do the evaluation. And thank you.